Okay, 8th grade Garnet Valley Middle School physical science students. Today we're going to do a virtual pulley lab, and I'm assuming if you're here on this video, you've already gone onto Schoology and opened up the lab sheet for this. And as we said in the directions, you can either print that out or just get a piece of paper and write down the data as we collect it here. And just make sure you want to use the right letters. Each box on the lab sheet has a letter associated with it, so you want to use that. So I have a block and tackle system set up here on this playground, and what block and tackle pulley means is that there are 4 pulleys for this particular one attached to the top of the playground, and then there are 4 additional pulleys on the bottom that will be attached to the cat litter. And when you use a combination of movable pulleys, the ones on the bottom move with the cat litter, and fixed pulleys, the ones at the top don't move, they're attached at the top there. That's what they call block and tackle. So in order to do this lab, we need to figure out how much work it takes to lift the cat litter. Let's say we're gonna go 30 centimeters off the ground. In order to do that, we're gonna need to know first how much this cat litter actually weighs in newtons, because we don't wanna work in the English system. So let's have a look at that. Okay, so we've hung the cat litter from the scale, and let's just go in there and get a reading. And that is 164 newtons. That's the weight of the cat litter and the container and that little bit of rope. And so we're gonna write that down under step 1, box A. Okay, so the next thing we need to do is figure out how high we're going to raise the cat litter. Now, I know you're looking at the video right there, and that piece of PVC says 30 centimeters. In fact, that is 50 centimeters, and that's because I cut 30 centimeters off, and then I grabbed the wrong half when I walked out the door. So there you go. We're actually going to go 50 centimeters high. So what we're going to do is we're going to raise the cat litter until the bottom of the container is at the top of the PVC. That means that the cat litter will have traveled 50 centimeters. So you're going to want to write down under step 1, box B, how far that's going to go. But if you remember from the earlier reading, to calculate work, you need to have the distance in meters. So you're going to have to convert 50 centimeters into meters, which shouldn't be too hard. You should be able to do that. If not, I guess ask Siri, because she seems to know everything. Okay, so now to figure out how much work you're putting into the system to lift the cat litter up, we're gonna need to measure how much force we're applying to the rope, and we will attach the scale to the rope, and we need to know the distance that the rope traveled. So what I did was I used this Mickey Mouse hand chip clip to mark where the rope is right at the pulley, and then we'll measure how far away the chip clip gets from the pulley to figure out what the distance was. Okay, so we're all hooked up. Let's give it a pull and just see how many newtons this takes. It's about 41 newtons, and I'm doing that with one finger. Just imagine if you tried to lay on your side and lift up a thing of cat litter with one finger, using just your muscles like that, how much easier this is now. This next shot, I've got to go in this format, up and down, so we can see the whole thing in action. So at the top there, you can see the chip clip right at the pulley, and on the bottom there, you can see the PVC pipe. Let's see how far that chip clip has to move to raise this thing off the ground. Still going. Hang on. Got to get another hand there. Still going. There goes the chip clip past me now already. Almost there. Get it so it's right level, right about there. Okay, so I tied off the rope, and the cat litter has been raised up 50 centimeters off the ground. And in order to do that, if you look closely at the pulley system here, we don't want to look at this rope, because this is the pulling rope. This is the one we're applying our force to. This is the rope where it's supporting the weight of the cat litter. And if you look at it, this thing's wrapped around like there's 8 pieces of rope on it. There's 8 segments. There's 1, 2, 3, 4 there, and there's 1, 2, 3, 4 there. So in theory, the weight of this cat litter is split up 1/8, 1/8, 1/8, 1/8. Each little segment here supports 1/8 of the weight. But in order to do that, for every inch you want, or every, we should say every, let's say every meter to make it easier, just keep it in the metric system. For every 1 meter you want the pulley to raise up, to lift the cat litter up, you have to pull out a meter on this rope, a meter on this rope, a meter on this rope, a meter on that one. You're gonna have to pull out 8 meters. So whatever we want, we have to pull like 8 times farther than what we want to raise it. So we raised it up 1/2 meter. So we should have had to go about 4 meters out. So let's just measure that. Okay, so we measured that off. The PVC fell over, but that was still there at 1/2 meter. And how far did we actually pull this? Now, unfortunately, my tape measure is in inches. So we're just gonna have to do a little quick conversion here. We're like at about 158 to 159 inches, probably closer to 158 because I've hooked the, come on, get in focus. There we go, good boy. I had to hook the tape measure onto the top of the pulley, so it's a little bit longer, probably about 1 inch. So I would say it's around 158. And if we do the math, 158 inches is about 4 meters. That is about 4 meters. So in order to lift that up 1/2 meter, get back in focus. Come on, phone, you can do it. There we go. To get that up 1/2 meter, we had to pull 4 meters of rope out of there. And that makes sense because, like we said, there's 8 wraparounds in there. And so for every 1/2 meter, we want that kitty litter to go up, we have to pull a 1/2 meter out of each one of those segments. So 8 halves is 4, and it works. After you write 4 meters in box E under step 2, you know the force we applied, which was 41 newtons, the distance we applied it, that's the work input, that's what we put into the machine. And you can figure out what that work was, and then you've already figured out the work output, and you've rounded those off to 2 decimals. Actually, you shouldn't have any decimals at all until you actually get to the efficiency part. And I swear to you, I did not plan this way, that the numbers came out this nice and even. It just happened. So when you calculate the efficiency for this machine, and the directions for that are in the lab, you're going to see that this was not the most efficient pulley system, but it was relatively inexpensive on Amazon, so there's a lot of friction in it. I could probably take it apart and oil up the wheels inside and maybe make it a little better. But it got the job done. If in a perfect world, if there were no friction and we could ignore the weight of the pulley and the rope itself, we should have been able to probably lift this with about 20 newtons of force. That would have been 1/8 of the weight of the box of cat litter and all that. But, you know, like I said earlier, when you use simple machines, they create a little more work for you, but it is easier work because I was able to pull that up very easily with one finger. I hope you enjoyed this, and stay safe, everybody.